Okay, this morning I'm just going to do a short video of a build I did quite a while ago. I had found a battery charger that belonged to my wife's father, who had passed away many years ago, and they were cleaning out an old shed that they had and found it, and I took it home and was looking at it and found out that it had selenium rectifiers in it. And, you know, believing the BS that people tell you about selenium rectifiers, I took the transformer out and basically threw everything else away, which was stupid. The idea behind it, what I was going to do, is I was going to take the transformer, which was rated at 8 amps, and make my own battery charger. And we'll get into why I was stupid for taking the other one apart here in a little bit. So I did end up building my own battery charger, but for the longest time it was mounted to basically a piece of wood, and I was looking for something to put it in. I needed a case that would hold the transformer, which was kind of large, and needed, you know, I had to source some meters and other things, a timer, but the hardest part was finding a case for it. I looked all over the place, and every place I looked, the prices of any kind of enclosure that would hold everything and give me enough room was ridiculous. It was like $30, $40, $50 for something big enough. And it was hard finding ones that were tall. A lot of them were short, and that wouldn't hold the transformer. And one day, when I was going through a Goodwill, which I at the time was doing a lot of, I found this. It's a carrying case for 16mm film reels, and I found two of them. This was the nicer of the two. The other, they'd been used to ship some film reels at one time, and they were completely covered in tape, and this one was the one that was the cleanest. And so I opened it up and I removed all the guts from inside, all the things that separated the film canisters. All of it came out pretty easily, and I had this really nice solid metal case that had an easy access to it. So I'll show you what. So these the amp meter and the voltmeter came off eBay. I'm not going to bother saying where I got them from. It's been a couple of years, and you can find, you know, you just use any voltmeter or amp meter you want if you want to build something like this. The neon bulb I got from a surplus place. They're really cheap. Switch is one I think I had. And this was the hardest part to find. This is an actual timer from a battery charger, and it's new old stock. I found a site after much searching over weeks and months. I found a site that had 3 of them, and I bought 2 of them. Since then I've gone back to the site, and the last one is gone, and I don't think anyone makes anything like this anymore. So basically this is what it looks like inside, and let's see if we can go in for a close-up. Get some more light in here. So what we have is mounted in the back is the transformer from the old battery charger. We have a bridge rectifier. We have the original 15 amp self-resetting circuit breaker, which anyways, the original 15 amp self-resetting circuit breaker. I mounted a fan, just a plain old 12-volt box fan. I didn't want the fan being run off of the voltage from the battery charger. I didn't want to affect that affecting the battery charging in any way. So I mounted a little wall wart transformer in here, and I put a little bus in here to, not a bus, but just some tie points so I could solder stuff to it, which I probably shouldn't touch that because it is plugged into the wall. And so the basic circuit is the transformer outputs voltage through the two red wires, cloth red wires, with a center tap that's green, and those go into the bridge rectifier. I'm only using two of the diodes in the bridge rectifier. It's not a full wave. I'm not using it as an actual bridge rectifier. It's more of a two diode full wave rectifier. You can look that up. It's true full wave rectification. But the voltage that it outputs is half of what a full wave bridge rectifier would put out. And I'll explain that here in a little bit. So it comes out of the bridge rectifier, goes into this circuit breaker, and then this part I had to order later. That is a buck converter, and that's visible in there. Yeah, it's not really visible. Yeah. So the reason I had to get a buck converter is that because this battery charger, the transformer came out of a battery charger that had selenium rectifiers. The forward voltage of a selenium rectifier, or the amount of voltage that is dropped by selenium rectifiers, and it varies by manufacturer, is about 1.2 volts or thereabouts. And so in the configuration they had, which was two diode, center tapped, full wave, you got out, I don't remember if I measured the voltage, but it would have probably been around 14.5 volts or thereabouts, which is what you would charge a battery with. Well, when I put this in here and I connected up to the full wave bridge rectifier, I was getting something like 33 volts out of it, and 34 volts, which obviously you can't charge a battery off of that. So I went back to just using the two diodes, where the positive comes off of the rectifier and the negative comes off the center tap, and that got the voltage down, but it was still too high. It was like 16.5 volts, and I found that I could get the voltage down to what it should be by using a variac to drop the voltage down to like 90 volts going into the transformer, but that just wasn't something I could, I couldn't carry around a variac all the time. I looked into various ways of doing it. I even tried putting a potentiometer on the input voltage. I found a 20 watt, 10 ohm potentiometer, and I hooked that up to the input of the primary of the transformer, but it only allowed me to drop the secondary voltage by about 1/2 volt, and I kind of gave up on it for a while. So once again, because they were selenium rectifiers, this transformer put out about 17 volts, and if you account for the voltage from the 60s, which would have been coming out of an outlet somewhere around 115 and 117 volts, then what you would have gotten from the transformer would have been about 16.5 volts, but with the forward drop, you would get a voltage drop of about 1.2 per plate, and there were two plates in the rectifier, and so that would get you would drop 2.4, maybe 5 volts, and so you would get the 14.4, 14.5 volts coming out of the battery charger. That's great. But with silicone rectifiers, they're a lot more efficient, and they only drop about 0.7 volts. And various things I thought about, and I finally broke down and decided I would do this with a buck converter. And so I bought one off of eBay that I will put here in the subtitles. The one I bought can put out 12 amps, and the voltage is adjustable from, I want to say, 30 volts down to like 1.5 volts or something like that, which, still using a full wave rectifier was too many volts coming off of this to put into the buck converter, so I still went with the the 2 diode center tapped rectification, which gets me 17 volts, which easily can go down to 14.4. So, and also the circuit board has a constant current mode where you can limit the current, and I set that at 8 amps, which is what the transformer is rated at. So the voltage comes out of this, and it goes to this Anderson power pole connector. Actually, it comes out, goes through the timer switch, and then through the amp meter, and then the Anderson power pole. And the way I've got it set up is I can hook up anything with an Anderson power pole with the correct polarity, just like that. And to demonstrate, we have a voltage that's coming in, it's exactly 14.4 volts. There's no amperage draw, and we'll put this on here. This is 2 ohm 100 watt resistors in parallel, which gets you about 1 ohm thereabouts. So when I turn on the timer, this will start drawing amperage, and you'll see this should, with the voltage without constant current mode, would draw 10 amps from this, but with constant current this should go down only up to 8, and the voltage will probably drop. So let's just do that, and you can see we've got about 7 going up to 8 amps. The voltage has dropped down to 8 volts, and that's completely what it should do. And the reason for that is you would want constant current charging in the initial stage of a really depleted battery. So you would hook this up, and once the battery started charging, the voltage would start rising, and then the amperage would start dropping, and then the battery would charge normally. And the way this timer works, I'm not sure, I think I wrote it down somewhere. I think it's like a 12 or a 16-hour timer, and this is off. Over here is a normal charge, and then this is equalize. And so if you had a battery, like a deep cycle battery, you would normally, if you fully discharged it, you would go here and you just let it charge until the thing went off by itself. But every once in a while you do a maintenance charge, which includes equalization, and so you would turn this all the way around to here, and it would charge it for an extra amount of time. The timer is powered by AC 120 volts, and it can switch 28 amps of current. So it works really good. I'll do it again. That's 7 amps. And I'll just show you if you take that off. So nothing happens with the amperage. that didn't even get warm. So, I think that's about it. Oh, there's just one. There is a vent on the bottom, and on the back of it there is, you got the fan, which draws air from the bottom out. And I suspended the I used some 632 screws to suspend the buck converter from the top. It was the only place I could find that I could support it and get it in the airflow of the fan. So, okay, that really is it. Thanks a lot.